All right, let's talk about something that feels so basic, so fundamental, we almost never even think to question it: logic itself. But what if I told you that our entire understanding of what logic even is has gone through this absolutely massive revolution?
So let's just start with a simple question. I want you to really think about this for a sec. Is every single statement you can possibly make either 100% true or 100% false? For centuries, the answer to that was a definite yes. But, as we're about to find out, that simple, clean answer started to cause some really big problems.
To really get our heads around this shift, let's use a metaphor. We used to live in a black and white world of logic, right? There was one logic with universal rules that led to absolute truth. But today, we live in a world of color, with many different logics, each designed for different purposes, for different contexts. So the big question is, how did we get from that stark, monochrome world to this vibrant, full spectrum?
Okay, so let's rewind and start by visiting that original black and white world. This was the era of what we call classical logic, and it was seen as the one and only way to reason correctly. Not just one way, the only way for everyone, everywhere, all the time.
Now, the absolute foundation, the bedrock of this whole system, was a rule called the principle of the excluded middle. It's a pretty powerful idea, and it's simple. Any statement, let's say the light is on, is either true or its opposite, the light is not on, is true. There is no murky middle ground. There's no third option allowed. Everything gets sorted perfectly into one of two boxes: true or false. Clean, simple.
And get this wasn't just a helpful suggestion. It was treated as absolute dogma. These weren't just seen as tools for thinking. They were considered the fundamental universal laws of thought itself, unquestionable, unchanging, period. But then, well, the unthinkable happened. This perfect, clean, black and white system started to crack under the pressure. This was the great foundational crisis that just blew the whole world of logic wide open.
So what on earth could be powerful enough to break logic? The answer is mathematics. Yeah, as logicians tried to use their simple black and white rules to build a solid foundation for all of math, with all its weird paradoxes of infinity and strange abstract ideas, things just started to fall apart. That one single set of rules, it just wasn't flexible enough. It couldn't handle the complex, sometimes bizarre, reality it was trying to describe. The system was just too rigid.
And out of this crisis came this incredible, revolutionary realization. A huge turning point. People started to think, hey, maybe, just maybe, one size doesn't fit all when it comes to logic.
This is what gave birth to a new concept called logical relativism. And it's really just the profound but simple idea that different problems might actually require different kinds of reasoning. And this is the key. Logic stopped being seen as a single, universal hammer for every problem. Instead, it became a whole toolbox, filled with all kinds of specialized tools for different jobs.
So, what's in this new toolbox? Let's take a little walk through the gallery, check out a few of these new colors of logic, and see exactly what kind of problems they were built to solve. First up, we've got intuitionistic logic. A good way to think about this one is as the logic of maybe. It's kind of like a Schrodinger's cat of proof, and it introduces a really fascinating and totally different way of thinking about what truth even is. Okay, so here's the wild part. In classical logic, a statement is true or false whether we know it or not, right? It just exists out there. But intuitionism says, whoa, hold on a second. Truth isn't something you just discover, it's something you have to create. You have to build a direct constructive proof for it. No proof, no truth.
And the consequences of this idea are huge. First, it completely throws out that old principle of the excluded middle. Suddenly, a statement can be in a third state, not yet constructed. It's not proven true, and it's not proven false. It's just pending. Which also means you can't just prove something is true by showing it's not false. Nope, you have to actually build the proof from the ground up. All right, our next color is a logic built for the messy, real world we all live in, the logic of indiscernibilities. Let's just call this the logic of close enough. Imagine you're trying to match two paint swatches that are almost, but not exactly the same color. See, classical logic really struggles with that kind of vagueness. It wants a clear yes, they're the same, or no, they're not. This new logic, though, it gives us the tools to reason about things that are almost the same or indistinguishable up to a certain point. It's a framework built to handle the limits of our perception and measurement.
And our final color for today is one of my personal favorites,
Paraconsistent logic. This is the logic of and yet. Think about it like this. You have a brilliant scientist's notebook. It's packed with groundbreaking ideas, but it also has a few contradictions scribbled in the margins. Do you throw the whole notebook away because of a few messy spots? Well, classical logic says, yep, you gotta. It follows this dramatic-sounding rule called the principle of explosion, where just one tiny contradiction lets you prove anything, which makes the whole system totally useless. But paraconsistent logic says no way. It rejects that. It says you can have a contradiction in your system, like in a messy database or an evolving scientific theory, and still reason sensibly about everything else. It contains the damage, which, as you can imagine, is incredibly useful in the real world.
Okay, let's do a quick recap to lock all this in. We have intuitionistic logic, our Schrodinger's cat of proof, which challenges the idea that everything has to be either true or false right now. We have the logic of indiscernibilities, our comparing paint swatches logic, which challenges the idea of perfect precision. And we have paraconsistent logic, the brilliant scientist notebook, which challenges the explosive idea that one little contradiction has to ruin everything.
So this all brings us to a really mind-bending conclusion. If we can have all these different logics, if we can choose our tools, what does that say about the nature of reality itself? How do these tools we use for thinking actually shape the world we see around us?
Well, this leads to a pretty wild concept, sometimes called the gnosological universum. The core idea is that the logical rules of our universe aren't something we just find. They're not something we discover. They're something we actively construct. The very logical structure of our reality is shaped by our own acts of observing, comparing, and abstracting. In a way, we are building the logical framework that we live in.
And this isn't just some fringe philosophy. It's an active, modern field of research. It's called the logic of abstractions, where scientists and logicians are actively studying how we build these logical models of the world and what that means for science and knowledge.
So, I'm going to leave you with this one final provocative thought to chew on. We've journeyed from a world with one set of rigid rules to a world with a whole toolbox of logics. But if we get to choose the tool, the logic that we use to reason about the world, does that mean that, in a very real way, we are also choosing the reality we describe? What do you think?